Alright, today we are going to take a look at distance, okay, and the idea of betweenness. A lot of what we end up doing in geometry, okay, we take an algebra aspect and throw it in there. So we'll look at solving simple linear equations today as part of what we're doing. So this first idea, okay, is the idea of betweenness. We got some line PQ. Right? Notice that notation, right? That just means some line that's got a point P on it and a point Q on it. And then we're saying that M is between points P and Q. Okay? Well, we can get a few pieces of information out of just that statement, right? Well, if M is between P and Q, well, that means all three of them have to be on the same line, first of all, right? All three of those points are collinear. And then it also means we can draw something like this, right? If N is between P and Q, we have no idea where between, but somewhere between, right? We can draw a line like this. And then we can also set up an equation to say, well, to get this whole length, to get the length from P to Q, I could take the length of PM and add the length of MQ. Right? That's what we're going to look at here first, and we'll solve a few problems with that idea. So, in this first example, right, we've got D is between E and F. We're given the length of ED is 1.2. The length of DF is 1.9. What's the length of EF? Oh, 3.1. Right? Okay? 3.1. If you're not sure, you can use your calculators. Use markers without toast. Make sure we label our answer. Right? 3.1 centimeters. Okay, now, we could do that one in our head, but technically what we did is set up this equation, right? We said ED plus DF equals EF, and then we substituted our known values in. So in this second example, okay, we're going to go through that whole process. We're going to throw a little bit of algebra in here. We're going to get a simple algebraic equation, but it is still algebra. So I'm going to set this up as AB plus BC equals AC, right? This piece plus this piece equals the whole thing. Then I'm going to substitute in the values that I know. Okay, well, in this case, those all have variables in them, but I can say that AB is equal to X, BC is equal to 2X, and AC, the whole thing, I'm told is 2X plus 5. Okay, then we just have a simple linear equation to solve for X. So, combine like terms over here. X plus 2X would be 3X. Then I want to get the X's on one side, numbers on the other, so I can subtract 2X over here. And I end up with X equals 5. And I'm done, right? Alright, the question asks for X and AC. Okay, so make sure that you answer the entire question. Okay? So we have to plug X back into our expression for AC. So say AC is equal to 2 times 5 plus 5. So AC is equal to 15. Okay. Questions on that idea? All right, so in the examples here, okay, there are, the first 4 are all numerical. So let's take a look at a couple of those first, okay? Let's take a look at a couple of these. So go ahead and try, just go ahead and try all 4 of these, okay? Pay attention to which piece you are asked for. Okay, you don't have to set up a full equation for these ones. Okay, these ones should be straightforward. Okay, except for maybe number 4. Number 4 looks a little bit weird. We'll talk about that one here in a second.
Oh, yeah.
Thanks. All right, what did we get for these? Like,
Yeah, 4.5.
equals 4.5. How about number 2 for BC? Carson. Say it again. 3 1/4. So forget my label over here. Here we go. 3 1/4 inches. How about 3? XZ is, we had 3.5 and 3/4. Summer? We should get 4 1/4. How about 4? We know how to do that one? 8?
3 centimeters.
Each of those would be 3 centimeters. So this notation is something we have not talked about yet. Whenever we see the same number of dashes or hash marks on a line segment, that means that they have the same length. Right? Another word that we will use later on in the year is congruence. Okay? It means they are congruent. Right? So just looking at this diagram, I know that WX and XY are equal. Alright, so that notation means they have the same length. So let's take a look down at 5 through 8. Okay, and I know there's not a whole lot of room here. You may have to use the margins. So here, we have to draw our own pictures. Right? For each of these, we are told that S is between R and T. Right? S is between R and T. So what would that diagram look like? So we have a line, right? We've got 3 points on there, and S is between R and T. So then for each of these problems, we are given some algebraic pieces. So in number 5, I'm told RS is 5x, in an ST is 3x, and then the whole thing is 48. Okay. We're going to set up a diagram like that for each of these 4 problems. So go ahead, let's take a few minutes and try that here. Also, make sure you're answering both parts of the question. Right? It doesn't just say find x. And you guys can talk to each other. You don't have to be silent here. Check your work with somebody else. Make sure you're on the same page. All right, do we have answers for all these? All right, I'll give you another minute here. Yeah. All right, do we have answers? Did we get x equals 6 and rs equals 30 for the first one? What about the second one? What is it? Say it again. X equals about number 7. Kate? Questions on these? Yeah. So, I know this is an extra step that kind of seems pointless right now. Right? But if you can just visualize what I'm saying, 5x plus 3x equals 48. But once we start getting into proofs and things like that, it'll make a lot more sense why I'm asking you to write this step first. Okay? It's going to be much easier to visualize things later. All right, let's take a look. Yeah, 12. Any other questions? All right, let's take a look at... Actually, we're going to skip 9 and 10 because that doesn't really have anything to do with this section. Let's flip over. Okay, and let's talk about distance between 2 points. Okay, we're going to do this in 1 dimension and 2 dimensions. Okay, and we could even do this in 3 dimensions. Okay, distance between 2 points in 1 dimension is pretty straightforward. Right, if we're just looking at a number line. Okay, a line is a single dimension. So all I'm doing is looking for how many spaces are in between these two. Okay, technically we, excuse me, technically we have a formula, right? But if we're just looking at a number line, right, and I want to say, well, what's the distance between -4 and 2 on the number line? Right, we're assigning points to those. So the distance between A and B, 6, right? And you can count the spaces, 1, 2, 3, 4, 5, 6, right, if you want to count. But this is just basic arithmetic, right? The second way, in 2 dimensions, okay, finding the distance between 2 points, and let's plot these real quick. So we're at 2, 3, 5. So 3, -5 is where we have C, or no, that's D, and then C is at -1, 3. So in 2 dimensions, it's not quite as easy as counting, right? I can't just count spaces to figure out the distance between these 2 points, okay? We have a formula, actually. This is our formula to calculate the distance. You will never have to memorize that, okay? You will always be given that formula. Later on in the year, when we start getting into triangles, we'll talk about where that formula comes from. Okay? It actually comes from the Pythagorean theorem. Right? But we'll derive that later on in the year when we do actually explore the Pythagorean theorem a little bit more. But for now, we are just going to use this formula. Right? In the formula, we've got x2, x1, y2, and y1. In each coordinate point, we have an x value and a y value. Right? So I'm just going to take my first point, label this as x1, y1, my second point, x2, y2. Okay? It does not matter. I could have labeled this one x2, y2, and this one x1, y1. That part does not matter. Okay? As long as we have one of the coordinates is x1, y1, the other one is x2, y2. Then I'm just going to substitute those values into this equation. So, square root of x2 is 3 minus x1 is -1. Whenever I have a negative value, I'm going to put it in parentheses so I don't mess up signs. Then plus y2 is -5 minus y1 then we're just doing some arithmetic. Right? So 3 minus -1 is 4. And -5 minus 3 would be -8. And I square those values. So what's 4 squared? 16. And -8 squared? Positive or negative? Positive, right? Any value squared is going to be positive. Add those together, we get the square root of 8. Did you guys work with simplifying radicals last year? Or not? Did you? Okay. So let's practice simplifying this. Do we remember how to do that at all? So there's actually a couple different ways to do it. I'm not sure which way you guys learned last year. The factors. So you guys, okay. So what are the factors of 8?
8 and 10.
So what are we looking for? The biggest perfect square that divides evenly into 80. Yeah. It was on the tip of your tongue. You know. Right? So the largest perfect square. Yeah, so I think maybe instead of listing all of the factors, it might be easier to try to divide the perfect squares into this number, right? So I think 16 ends up being the largest perfect square that will divide evenly into that, okay? I mean, you can use your calculator to figure that out. Do you guys know the perfect squares just off the top of your head? You know, 1, 4, 9, 16, 25, 36, right? So we just want to take those numbers and see if they divide evenly into 80. And I mean, you just start trying them, right? So start large, okay? The largest number you would have to try is about half of 80. Okay, so we can start with 36 and start going down from there. And the largest one we find is 16. So what do we do with that information then? Okay, so 16 in the square root. And I think I heard. Yeah. So all we're doing is splitting 80 up into 16 times 5, right? Both of those numbers will still be inside of the square root, right? Well, neither of those are a perfect square. So the next step is why we just want to look for perfect squares. I can take the square root of 16 now. What's the square root of 16? 4. Right? So this would simplify to 4 times the square root of 5. Square root of 5 is like 2.4 or something. What's that? Well, this is our answer, right? We can't simplify the square root of 5 any further. There's no perfect square that I can take out of that. But we took out the largest one that we possibly could.
Oh, I see.
16. Right? So, that, I don't know, do you guys feel comfortable doing that? Okay. So, let's try a couple more down here. We have 7 minutes. All right. Yeah, that's not a bad idea. Well, so tomorrow and Thursday, we have to do the MAPS test. So it's an online test. It's a diagnostic test just to see what math you know.
Oh, it's start.
Sure. I don't know what the STAR test is.
You know, like iReady? What? iReady.
So no.
iReady?
So yeah, it's similar to iReady. The STAR test apparently it's just a diagnostic test. So we're doing that tomorrow and Thursday. So you need to bring your Chromebooks. Make sure they are charged. This is all online. So bring your charged Chromebooks to class tomorrow. So I wasn't planning on having homework tonight, but
No, I read mine. No. First one was gonna give us the
so how about we've got 6 minutes left? Why don't we try to get as much of this done as we can in those 6 minutes? Okay, 1 through 6 are hopefully really, really easy. And then 7 through 10, we're using that distance formula, okay, to determine the distance between points. So eventually, it doesn't have to be done for homework